Hey everybody, Michael Snyder, El Nino Weather Watch. Today's December 3rd, and I thought we'd go ahead and take a look at the latest on El Nino. First of all, we're going to describe exactly what it is and how it affects things and what our forecast limitations are with regards to El Nino. You can see it's between 170 west and 120 west in the Nino 3.4 region, south of the Hawaiian Islands, across the equatorial Pacific. You can see Australia, you've got North America, you've got South America here, and we are currently in an El Nino. And you can see it here. We've climbed out of this La Nina since last December, and now we have been warming up. So we've gone through the summer, the fall, and now on into the winter months here. And we are very warm across the equatorial Pacific, 2.1 above normal. That's starting to approach on super El Nino status if we can hold that for 3 months. But right now, we're probably going to be still going for a strong El Nino. Now, taking a look at this, you can see as of about May, June, July, August, September, we are now officially in El Nino conditions here. And of course, we're going to continue this on. We're probably going to be somewhere around 1.7 or 1.8 for October, November. So probably qualifying for that strong El Nino. And again, the latest weekly value here, you can see it across the equatorial Pacific in this very warm tongue of water coming off of South America and extending out across the equatorial Pacific Ocean. Now, this is what's called outgoing long-wave radiation anomalies. So this blue, this shows you where the convection is, where the clouds are, where the thunderstorms are, above average across the equatorial Pacific. And that makes sense, right? That's why we have the warmer water there. So it's helping get those thunderstorms going there. And you can see the below average convection here across the maritime continent. Kind of a classic El Nino signature there. Here we're looking at normal conditions across the Pacific Ocean. You can see the Walker circulation generally situated here across the Western Pacific. Trade winds tend to push that warm water heated by the sun, and it kind of culminates here in the Western Pacific Ocean. If we take a look here, again, typical conditions, warm water here helped by the currents, and of course trade winds and the general flow of the wind here picks up that warmed water, and it kind of builds up here in the Western Pacific Ocean. Now, I'm going to show you here a prevailing wind pushes warm water along the surface, and you can see it accumulates there generally in the Western Pacific here, even though it's still warm water. Of course, it is the tropics down there across the equator, but it is warmer there across a lot of the Western Pacific. And of course, where you get that warm water bunching up, you tend to have increased convection, and that's known as the Walker circulation. Now, La Nina conditions kind of enhance that trade flow here, and it pulls some of this water away from South America there, and it helps with the upwelling there. We extend this cold tongue out over the equatorial Pacific. You build up the heat even further across the Western Pacific, and then you bring that Walker circulation here, which of course changes Rossby waves and ridges and troughs downstream, and it can affect the weather greatly across North America. However, during El Nino, you have that Walker circulation reversed here, and you bring that deep convection out over the central Pacific here, and we build warm water all the way up on the coast to South America, all the way south of Hawaii across the equator there in the Nino 3.4 region. And so when we bring some westerly winds, or we even slow down the trade winds enough, you start to warm up the water there across the eastern and the central Pacific. And so the Walker circulation starts to move back out over the ocean there, south of Hawaii across the equator, and across that Nino 3.4 region here. And so how do we know if that Walker circulation is starting to show El Nino conditions? Well, one way is to look at the Southern Oscillation Index here. So we have Tahiti there, and we have Darwin. We take pressure differences between the two, and we can kind of see where the Walker circulation is setting it up, and if it's, kind of following along with what the ocean is doing as well, El Nino versus La Nina. So if it's in El Nino conditions, you should have lower pressure here and higher pressure here. Of course, that would be higher pressure in Darwin, lower pressure in Tahiti during El Nino conditions. And that's if the atmosphere is responding. During La Nina conditions, you got lower pressure out towards Darwin, higher pressure over Tahiti. So where are we now? So there's the triple dip La Nina, and we have been in positive for a while, showing that we've been in La Nina conditions. The atmosphere responded quite nicely. But now look at the very end of the run there, October 2023, we are in negative territory. So that means the atmosphere is starting to show El Nino conditions. The Walker circulation switching up a little bit there. And again, you can see that positive La Nina here where the high pressure is more over Tahiti here, and it pushes the wind even more off to the Western Pacific here where that warm water builds up, and we get that deep convection here, and it changes the jet stream downstream. And the opposite happens here in El Nino. We've got more convection out here across the equatorial Pacific. And you can see they keep a 30-day and a 90-day running average here, and we're in negative. It's been actually climbing a little bit here as we've been going through November and into early December here, but for the most part, we are still negative as we go. Here we're looking at the Climate Prediction Center for December, January, and February going on into 2024. And I've saved September, October, and November's forecast. You can see they look fairly similar. The above average conditions across Pacific Northwest, and they've included some of California, especially with this next November forecast here. There'll be another one coming out in December. Probably will look something similar. Here we go with December, January, and February. You can see September's forecast, October's forecast, and November's forecast. We're looking at above average still for California, some in Nevada, Arizona, and kind of southern Oregon included there. And the below average signal here across some of the Pacific Northwest actually backed off a little bit as we brought this new November forecast in. It does include Idaho and Montana, however. Now, if we look at September, October, and November's forecast here, this one being the most recent, of course, we're looking at January, February, and March. You can see how they kind of included California a bit more, and the above average signals stuck the last 3 rounds here for much of the Pacific Northwest. Taking a look at January, February, March precipitation expectations here. So you can see we got an uptrend in that forecast in October, and we kept it above average here with the most recent in November here. So that's a good sign for the Southwest for some above average precip. However, for February, March, and April, they kind of dropped things back down. They still left it here at equal chances, but the Pacific Northwest kind of still hovering around with that below average signal all the way on through the early springtime coming up. And this is also looking at seasonal temperature for the same time frame, February, March, April, above average for the Pacific Northwest, kind of including maybe the northern half of California there. Now, taking a look here, NOAA has compiled the 7 strongest El Niños since 1950, and you can see the one that threw the monkey wrench into everybody's forecast here, 2015-16, expecting the wet California there. Of course, strong El Nino kind of taught us a lesson there. Doesn't necessarily mean wet California just because you have a strong El Nino. The storm track was there. It just pointed into the Pacific Northwest, brought some very heavy precipitation up there. But look at 82-83, 87-88, 57-58, 72-73, 91-92, 2009 and 10, all favored a lot of areas of California for that above average precipitation. That's why our confidence is on the higher side for above normal precipitation for the state of California. Now, if we take a look here, this is single forecast member good match. You can see that we're expecting, again, a wet California and kind of a dry Pacific Northwest. This is what things should not look like. So if our forecast is completely 100% incorrect, then the Pacific Northwest is going to be really above average and California would be really below average here. So here's the ensemble mean of December 2023 to 2024. And you can see California favored here, some of the Southwest and the Pacific Northwest below normal. And here's the expected El Nino precipitation pattern right here. And again, California favored generally during El Ninos. Now here we're looking at precipitation match. Does this match the expected ENSO pattern? And there's that 2015-16 there, we're bringing it up again because it did not play nicely. You can see the 97-98. It did El Nino things. It brought precipitation to places during El Ninos that are supposed to get precipitation. You can see it spent most of its time in that expected territory there. And 2015-16 did not look like a standard El Nino there. And there's reasons for that, but we're not going to get into it just yet here. I think I have a couple slides on that later on right now. It has to do with just how warm that water was across the equatorial Pacific versus all the way up against South America. But anyway, taking a look here, we don't have last year's La Niñas in here because last year did not act like a typical La Niña as far as California was concerned. But we do have this overall kind of trend here. When you get towards stronger La Niñas, you generally get precipitation in areas where you expect it to be. And that's kind of the general rule as far as El Nino is concerned. But as 2015-16 taught us, that is no guarantee. And this kind of shows you that confidence does increase once you get towards the strong El Nino. So, again, we're kind of reset things here and, we're favorites to get some above average precip here across California. But of course, it's no slam dunk. Now, taking a look at what we're headed for as we go into next year, we're going in towards a neutral pattern coming up here, which can be pretty exciting across a lot of the west coast of North America as well. Can bring some interesting storm systems, or maybe we'll even drop back down into a weak La Nina. Now, let's look at Rossby waves. So this kind of shows why we have just this natural variability, even during El Nino or La Nina years, you're still going to have rain events and you're still going to have wind events and you're still going to have certain storms move through just because the general pattern of the polar vortex kind of swings these Rossby waves through, and it's going to bring storms even in years where you're supposed to be dry or years where your temperature is supposed to be above average. You're still going to get times where it is chillier than normal based on where these Rossby waves set up. And here we're looking at the northern hemisphere here, so it kind of shows you where these Rossby waves go and how they move. And sometimes I'll show these in my daily briefings as well. So, that's why it's always worth to check back daily. If you have, big interest in the weather, if you work outside and whatnot, it's always better to hang on and wait as long as you can with the forecast, and always to check back with forecasts, because you don't want to be looking out 10 days and kind of get something in the back of your mind on what you expect, next week, and not check back, especially if you have interest in, if you work outdoors or whatever, if you have interest going on or you're traveling, for example. So here we go, the gradient between the polar and the equatorial regions. You can kind of see it, that colder air, again, across some of the polar areas here. And the mid-latitudes is known as where this air masses meet. And that's where we get those storms. Those mid-latitude cyclones form right on that boundary between the cooler air and the subtropical air. Now, the stronger the gradient, the stronger the winds, the stronger the storm out there. And again, this is showing Rossby waves. These are always present in our atmosphere, and especially in the winter months there across the northern hemisphere. Taking a look here, I want to point something out for the 97-98 El Nino versus the average from 1968 to 1996. What do you see here? Basically, we're looking about 39,000 feet up in the atmosphere, and you can see the jet stream. And it extends out and it starts to get close to Hawaii there. But if you look at El Nino, this drives all the way across towards Southern California. That's why Southern California had above average precipitation. This tropical and subtropical jet was much more active, so it brings more moisture and more storms into the area there versus the typical setup. Now, taking a look at February, March, and April here on the right versus November, December, and January here on the left. What do you see the differences are here? The Aleutian low is stronger. You've got a more powerful subtropical jet stream here. The gradient is stronger. The storm is going to be stronger. You're going to bring atmospheric rivers and systems into California with more regularity versus November, December, and January. That's why some people ask, hey, why isn't El Nino showing its face yet? Why aren't we getting hammered with atmospheric rivers in California? A lot of times these things don't get going until you get on into the new year. Now, the Madden-Julian oscillation is another thing. This is very similar to El Nino in its own right. This is basically an area of enhanced convection that moves across the planet about every 30 to 60 days. And it kind of moves from the Indian Ocean, across the maritime continent, and out over the Pacific Ocean. And it can kind of mimic what El Nino does, but sometimes it can play in tandem with El Nino also. So if El Nino is kind of emerging across Pacific Ocean and the Madden-Julian oscillation is moving across Pacific Ocean and it's merging with El Nino there, you can get even enhanced convection in those areas. Now, taking a look, this is the Pacific Ocean. There's the Hawaiian Islands. You're looking at Japan here. There's North America. This would be Madden-Julian oscillation phase 3. Then 4 would be there, 5, 6, 7, and then 8 as it transfers across the planet. Then it reemerges back over there across Africa and the Indian Ocean. So this is phase 3 here. And so you'd have that deeper convection out across the Indian Ocean, and you bring a strong jet stream maybe across the portion, off the coast to Japan here. And then you bring a big ridge of high pressure here, and you get some maybe cooler air, northwest flow here. Kind of looks like La Nina. However, as that Madden-Julian oscillation moves its deep convection out over the Pacific Ocean, which kind of looks like El Nino, as we talked about, the Walker circulation would be out over the central Pacific there. It can really enhance things here. You get some colder air spilling out over the Gulf of Alaska. You get that warm tropical air. And then, of course, you've got that strong gradient. The big difference between the warm and the cold air subtropical jet just slams into the coast of California there. Hope that makes sense. So here's a little bit of West Coast data for you here. And again, as we mentioned, wet winters are not a slam dunk. However, you can see 97 in 2003 up here showing the very wet California. But you can also see that there are El Nino years that are below average for portions of California, and likewise with La Nina. So you're just kind of dealing with probabilities here. And this is North California, February, March, and April here as well, showing again very wet during those strong El Ninos. But of course, that got totally changed up with the 2015 and 16. Now, look what happens when we go on into the new year here for basically, this is Los Angeles International Airport from 1950 to 2023. Check out El Nino conditions versus La Nina. You're looking at quite a bit more rainfall here. Look at the average for January, 3.65 versus 2 inches in La Nina years. So you can really see this come alive. I mean, even December La Ninas are generally wetter than they are for California versus El Nino years. But as you get into January and February and March, you're getting significant more precipitation showing up. But you can see you're still getting rainfall during these La Nina years. And at some periods of January, February, and March, you're not going to be stormy all the time. It's just a general increase, but it is notable there. Now you can see from 1979 to 2023, look at La Nina, January through March, 6 inches. Neutral, January through March, 6.5. Look at El Nino, January through March, 10.03. So that is notable. And that's why, and that just kind of lends to what I've been saying here over, the last few weeks. And every time I talk about El Nino in my daily briefings, that it usually doesn't get started until the new year rolls around. Now here's Los Angeles, 1979 to 2023. We got La Nina. We got La Nina January, strong La Ninas here. And then you've got the strong El Nino January through March. And given this is not a huge sample size here, but is a very noticeable signal here. When strong El Ninos, we really ramp up the probabilities for precipitation potential into Southern California. And this is Sacramento, California. Look at January. That's pretty noticeable there. In January, I mean, you're looking at about 1.3 inches more precipitation. February, you're looking at almost an inch more, about 0.85 or so. And then March is also rainier. And even April, look at that, 1.6 on average versus the 0.93 you get. But look at La Nina. So you might think, hey, look at, it's raining. Well, where's El Nino? How come it hasn't rained as much as it does in La Nina years? And that's generally because that difference doesn't really get cranking up there. But you can see it once you get into the new year. This is Las Vegas. There's also a signal out there. Look at El Nino years as a general rule. 5.39 inches of precip versus 3.1 during La Nina years. That is pretty darn right noticeable. I mean, some of these months you're well up over twice the amount. And April and May are generally wetter also. But you can see not much of a difference between December La Ninas and El Ninos for Las Vegas. This is Lake Tahoe snowfall. So you can see La Ninas are generally a little bit snowier there. As you can see, about 21 inches of snow or so more. But actually January, a little bit snowier in Lake Tahoe there. But then you start dropping back down as you get towards March. You got a little bit less there as well. And maybe the Decembers are a little bit less there also. But not a huge difference there, as you can see. Now, if we look off here to the right, you got California and you've got Oregon here, and you can see Crater Lake during strong La Ninas versus strong El Ninos. There's a pretty big difference showing up there. Government Camp, pretty big difference. I mean, you're looking at 202 average versus 370 across Oregon. And also for Howard Prairie, you're looking at pretty big differences. Not always the case in California, though. However, as you can see, at 6,700 feet, the strong El Ninos actually average higher snowfall amounts versus a strong La Nina. That's because increased moisture content. Manzanita Lake there, check it out. 207 versus 203, pretty close. Mineral, pretty close. So we're not looking, depending on your elevation, El Nino is definitely not death to snow across California. The Sierra Nevada can still pack it in, even in El Nino years, depending. Now, taking a look at Northern California here, and you can kind of see this. You can see some of this El Nino, the 82 and 83 versus 97, 98. Again, very wet years here, but there are El Ninos that were coming in below average here. And you can kind of see the Northern Sierra precipitation chart in which areas it includes here. But yeah, it's no slam dunk by any means, precipitation-wise. And again, for Central, 82 and 83, 97, 98 are the kings, but there are El Ninos that come in below average. And Southern California here as well. Actually, you're getting into the Tulare Basin there in California, strong El Ninos between 57, 2016. And again, you still can have El Ninos that show up a little bit less than average. So looking at 2015 and 16, I do have these slides in here. I couldn't remember if I included these at the end, but here they are. So why didn't it bring big rains to California? This is kind of the hypothesis going around, or theory, whatever you want to call it. But here we go. So you can 2016, you can see kind of that heating out over the Central Pacific Ocean, a little bit less up against South America there. And 1998, January 31st, you can see it kind of butted up against South America a bit more, but still plenty warm across the Central Pacific. So what happens here? Basically, that Walker circulation was most likely offset a bit further to the west there. So this probably brought that increased moisture flow up into the Pacific Northwest versus that warming here, keeping that Rossby wave probably, not the Rossby wave, but the Walker circulation, which does have influence on the Rossby waves, but it kept it a bit closer to the coastline here and allowed that subtropical jet to bring more moisture into California versus up into the Pacific Northwest in the 2015 to 2016 time period there. And this is the ELI, the ENSO longitude index, which would come into play with that because you could see where the warmest water was located from South America out across the date line. And we're still in our infancy as far as forecasting this stuff. We still have a fairly small sample size. It'll be interesting to see how good we get at this over the next few decades because computational power is always increasing, and I have a feeling we'll probably get a lot better at it here in the next 20, 30 years here. And of course, the more time and the more information, the more data we have to work with, the better our forecasts are going to get. So we're still in the infancy. At least we understand these phenomena and these oscillations and whatnot because they're pretty interesting here. And eventually we'll start to put it together where we can make better, longer range forecasts. But we still have an idea what's going on out there as of right now. Now, taking a look at the anomaly plume here. So this is all the way back in September 2022. And so this is what actually happened, the blue line. But you can see the forecasting for the La Nina or the ENSO conditions across the equatorial Pacific are pretty good. You can kind of see how it followed along a lot of these ensembles here. You know, we thought it was going to warm up by the time we got in towards the late winter and the spring, and we did. And then you can see the October 2022 here, pretty good. You know, that blue line kind of following along what the ensemble members said would happen. Same thing for November and December. Look at that. This blue line, again, is what actually happened. And the forecast picked up on this well in advance. You know, we can predict these things with pretty good accuracy right now. It's not always perfect, but it's not bad. As you can see, here's the January forecast, the February forecast, well within the ensemble range here. And here we go with March and now April, pretty good. And now here we go with May and then June, maybe a little bit less than what we thought there with the June one. Not the best one there. Here's July and here's August. And you can see as we get further off into the forecast here, we don't have, obviously, we're not into February just yet. But this has been doing pretty good because right now we're in December and we're at 2.1, so about right there. Not bad. November would have been right about there. October down here, maybe towards 1.5. So maybe this was on the higher end of things here, but generally had that prediction pretty close here overall. And again, 2.1 would have been right here for the September forecast, and 2.1 in December would have been right about there. So right within the ensemble range. So pretty good at forecasting these ENSO events out in advance. And this is the November 1st one here. Actually, you might have got a little bit above on the high side of the ensembles with the most recent one there. But anyway, hope this clears things up a little bit for everybody out there. You know, it's always fun to watch these forecasts come in, but we're still just dealing with probability, as always with weather. If you have vested interest in what is going on outside, for example, it's always worth to just check back. You know, once you see an 8 to 14 day forecast, you really need to check back if you have big concerns with what's going on with the weather. I mean, as soon as a forecast goes out, it starts to change. You can really, you know, you can read that. If you read the area forecast discussions, if you go to NOAA and search that, a Google search for area forecast discussions in your area, you can kind of read about this information. And they put these out 4 times a day for a good reason, because the forecasts are always changing. That's why models run 4 times a day, or in some cases, like high resolution models are running 24 hours a day, you know, because the atmosphere is always changing, and we don't have this. Our sampling of the atmosphere is still not that great. So we have planes flying through, and we've got surface observations, and we can break things down in that manner, but it's not the same as if we had some kind of high resolution sampling system covering every square meter of the atmosphere from the surface to 60,000 feet up. And then we had the computational power to grab all that data and make a forecast. Of course, information, you know, our forecast would become much better. But, you know, I'm kind of getting off on a tangent here. But anyway, would just kind of check back daily. That's the most important thing you can do. And even when you have a big storm, like during the season last year when we had La Nina bringing those big storms down into California, it's hard to determine exactly, is La Nina driving this? What's going on? What's driving this change here? Is a Mad Julian oscillation coming through? It's difficult to say. So it's always worth it to check back on these forecasts. I can't drill it in enough for that. But hopefully this whole thing's been educational for you guys and kind of giving you an El Nino update here. But anyway, I'll do my normal briefings tomorrow as well. Some exciting weather here coming up in the Pacific Northwest. I might be live streaming here on the next couple of days as well with that. But I'll do my normal California briefings tomorrow morning in Pacific Northwest as always. So anyway, hope you guys are liking these videos. Click like and subscribe. I will talk to you guys tomorrow and I'll see you then.